Welcome everyone. I'm Keith Patterson, and I will be joined today by Matt Brown. I am the Field Services Manager of NAFTA for TerraSource Global. Matt Brown is my Field Services Supervisor for the power and mining side of the business. The maintenance basics presentation today is intended to be a fairly generic overview of basic maintenance requirements for a wide variety of Gunlock, Jeffrey Rader, and Pennsylvania crusher equipment, and will assist you in putting together maintenance planning for your specific machines. Of course, every one of your specific machines comes with an operation and maintenance manual, certified drawings, and a lot of technical information specific to your unit, and we can talk to you about specifics of your unit later or at your convenience as needed. First of all, we get a lot of questions as to who is TerraSource Global. I'd like to take this opportunity just to show you a few slides to try to clear up some of that confusion for some of you. We have three globally recognized brands under the TerraSource Global umbrella company. The Gunlock brand is best known for its single and two-stage double roll crushers, mainly crushing coal at the mine mouth and preparation plants around the world. This equipment also is found in power stations, salt processing plants, and other fertilizer manufacturing facilities. Our Jeffrey Rader brand of equipment includes material handling systems to unload, convey, screen, and crush many different bulk materials, from wood and pellets to biomass, alternative fuels, and other recyclables. Very diverse product line, including crushers, wood hogs, vibratory feeders, pneumatic conveyors, rotary airlocks, screens, chain and reclaim, screw reclaimers, other metering and storage bins and silos, and a lot of other older lines of equipment that you still may have out in your facilities operating. Our Pennsylvania crusher brand includes many crusher types that of sizes and configurations, also built to customer specifications, built to order units, for granulators, posimetric feeders, and they're used throughout the coal-fired utility industry for generating electricity. This slide just shows a breakdown of the different types of machines for size reduction, posimetric and vibratory feeder lines, and the material handling lines. The Gunlock crushers, obviously the roll crusher comes in several configurations, 2-roll and 4-roll. Nanosizers for fine grinding, cage mills, and high tonnage breakers. The Jeffrey Rader size reduction equipment comes in many models for processing the various materials and industries. Our vibratory feeders are used throughout coal, aggregate, mineral, and steel industries, and other numerous alternate areas. The Jeffrey Rader pneumatics are a dilute phase type of pneumatic system for conveying biomass, MSW, which is municipal solid waste, RDF, which is refuse-derived fuels, and sludge handling. Screening and processing lines of equipment for classifying numerous types of products. Storage and reclaim systems, very many numerous designs, and the material handling from truck dumpers to screw and belt conveyors, hoppers, and bucket elevators. So it's a very diverse product line offering. In the Pennsylvania crusher line, we have the Mountaineer Sizer that's used mainly at the mine mouths for coal and some of the limestones. We have the coal pactors for impacting and breaking the coal at the power plants into finer, like quarter Bazira coals for being fed to the boilers, posimetric feeders, and Bradford breakers. These show some of the units. They are some of these Pennsylvania crushers are quite massive, as shown in this single roll crusher. The jaw crusher is a primary crusher used for glass and cullet and limestone and coals. Also the granulators for fine grinding and the reversible impactors. TerraSource, to consolidate, we have closed the 3 specific brand labs, the Gunlock Lab in Belleville, the Jeffrey Lab in Woodruff, South Carolina, and the Pennsylvania Crusher Lab in Broomall, PA. And we have moved all 3 of those test labs and consolidated into one new, very impressive, large test lab that is located in Duncan, South Carolina. And this is just a couple of the shots showing the installation of the various Gunlock, Pennsylvania Crusher, and Jeffrey crushing and conveying equipment. At this point in time, I'm going to turn the presentation over to Matt Brown.
Thanks, Keith. The reliability-centered maintenance is the maintenance that was phrased 30 years ago, but it's determined the best maintenance task to implement in your maintenance plan. The goals of the RCM is to ensure that the right maintenance activity is performed at the right time and with the right people. The 7 questions of the RCM are as follows: the functions, fail to fulfill its functions, what causes the failure, when the failures occur, the consequences, predict of the failure, and the proactive task cannot be found. Who answers these questions? The RCM team may include the supervisor, planner, craftsman, operator, engineer, manager, or facilitator. What is the result? The result is the right maintenance at the right time, operating procedures, design modifications, expectations, and of course, more reliable equipment. That's the goal of everyone. Scheduled restoration tasks. This is when you want to work on the task of your equipment on your own schedule. So if you have an outage coming out once or twice a year, you want to take that time, take it in there and restore your equipment. It's possible most of the items survive to that age and the tasks are carried out to restore to the original resistance. Proactive tasks deal with the age of the items, and these tasks are routine items. Default actions are the failure finding, redesigning, and the run to failure. These are the actions that you can't necessarily control. What is planning and scheduling? Well, it's defined as the details of what and how. Scheduling defines the details of when and who. Refers to the timing of the work as well as who will complete the work. Why do the planning and scheduling? Well, with the planning and scheduling, you can focus on the quality of the task at hand. It's most likely cost effective, and work will be executed in a highly efficient way. There's no scrambling, try to get things put back together. You have a plan, and you want to schedule it, and you take care of the maintenance that needs to be done at the appropriate times. The types of maintenance are the breakdown maintenance, the preventive maintenance, periodic maintenance, and predictive maintenance. Corrective maintenance and maintenance prevention are also two items that are included in the types of maintenance. Failure finding inspections and on-condition inspections also help to plan and schedule your equipment for outages and for repairs. Schedule preventive maintenance, taking care of problems before it breaks. Services may include the lubrication on a scheduled basis, repairs on a scheduled basis, or replacing the equipment on a scheduled basis. The failure effects. What happens when each failure occurs? When you have a failure, of course, you want to find out why the failure has taken place. So these are a couple things to look for when you run into the failure mode. What evidence that the failure has occurred, the threat to safety or the environment, ways it affects production, physical damage, and what must be done to repair the failure. Now we're going to talk a little bit about bearing and drive components. In all of our machines, bearings are a big part of the machinery that we manufacture. And it's important to keep the bearings well lubricated, well maintained, inspected, and the proper lubrication levels. You also want to make sure that you're using the correct bearings for the type machine that you're repairing and operating. You want to keep the bearings in very good shape. These are the heartbeat of a lot of our machines. You want to avoid the entry of dust. You want to clean the bearings periodically. Failure to do so will create bearing failures that are premature. Also want to monitor the vibration when you're checking on your bearings. There's a lot of systems out right now where you can go in ahead of time, or this will fall under the preventive maintenance of bearings, to come in and verify your vibration, whether it be weekly, monthly, quarterly. Come in and just verify the vibration of bearings, and you should be able to see a pattern if your bearings are beginning to fail or you're beginning to show excessive wear. You also want to monitor the temperature of your bearings. Normal operating bearings in most of our equipment, again, this is just brief through all of our brands, in an overall range of 140 to 150 Fahrenheit. While the bearings in the gear drives operate from 155 degrees to 165 degrees Fahrenheit. These temperatures should be monitored and documented. We also have Gearbox that operate some of our equipment in the drives. And again, these items should be inspected regularly, and the lubrication should be observed to make sure you get the most life out of this equipment. Some of the effects of the gearbox defects include the improper position of the motor against the gearbox, tooth separation caused by bad machining, failure caused by a fracture of a tooth or a chipping of a tooth tip, a broken tooth. Low backlash between two wheels will reduce less area of contact. So these are things that you need to monitor and to verify on a periodic basis. And again, here's a list of some of the items we put together that are used a lot in our equipment. The V-belts, the couplings, the hydraulic components, the bearings. This is something you can look over to verify the standards, the best practices, and the consequences. Wear parts. With crushing equipment, you have a lot of wear parts that are internal. These parts need to be inspected on a periodic basis to ensure that you have the proper operating conditions within your machinery. If you can't see these parts when the machine's actually in operation, you may have to shut the machine down and opened, once the machine is locked out and everything safety-wise, to get inside the machine and take a look at some of these wear parts, internal parts of the machine. These also have to be inspected regularly. The rotors fall into this category. A lot of our machines have rotors with swinging hammers, solid hammers. We have cage mills with the cages. You all have rotating devices that may or not be called rotors, but there's all rotating equipment between bearings. They also need to be inspected periodically. Again, talking about lubrication, we got several points of lubrication, whether it be by grease or by oil. Each brand has their own manuals that can provide the specifics on lubrication, on what your equipment is recommended, the grading, and the different brands of oils and greases that we recommend. I put together some daily checks for a pre-start. These are daily checks on machinery, and you have a chance to take a look at these pre-start checks. I mean, you want to go check the crushing chamber when possible, the clearance between the hammers, side liners, screens, check the cages and screens, check the hammers and screen conditions, check for loose bolts, guards, covers, and if when applicable, your hydraulic fluid or oil levels. These are some daily checks that can be done with our equipment. With the equipment startup, these are also some items to follow while your machine's coming up to speed. You want to inspect the crusher and remove any excess of material buildup. Start the conveyors, start the crusher and note any vibration. Check and log the motor amp draw. Introduce the feed to the machine, whether it's to a feeder or a crusher. And you want to listen and feel for unusual operation. And again, visually inspect for loose hardware. Then we also have weekly checks, where not as often, but you still some important items that we want to look at each week. After shutdown, you want to check and log bearing temperatures. Again, hardware, the seal arrangements. Check the crusher frame for any cracks or repairs. If you're using V-belts, you want to check the tension and condition of those, as well as your hydraulic components. And then the monthly checks, a little less extensive, but we also want to check for wear in the feed chute, your chains or rock curtains. Check under the crusher for wear, and in the discharge chute. And then annual checks, the grease the motor once a year as recommended. If the machine has hydraulic, you want to change your hydraulic tank and clean it, empty the oil and clean it. By doing all of those items, you'll get a lot more life, or you should get a lot more life out of the equipment. That applying this kind of maintenance will help provide for planned shutdowns before you have severe damage. And then the causes of the failures can be analyzed. Thank you for your attention. Now we'll take any questions anyone has.
What advancements have been made regarding hammer and cage mill material selection, especially as far as erosion and corrosion? Has there been any development to extend the life of crushing rotating components such as hammers and mill cages? And he's specifically speaking about the potash industry applications.
Well, we have an answer for that. We're using, in a lot of circumstances, the Jeffrey Ultra Alloy hammers, especially for the wet crushing applications, where the manganese corrodes and erodes. To this point, we have some success with this alloy, using it in these circumstances, and we're always looking to improve. And we have, as Keith pointed out, the R&D department, which was brand new, and we're always adding new parts and new equipment to the existing machines that we have our facility, that we can test a lot of these different materials, always looking to improve.
He says pressure continues to rise with maintenance teams to reduce MTBF. What can the industry expect from both Gunlock and Pennsylvania Crusher brands regarding continuous design improvements to the maintainability of their crushing equipment?
The hard-faced hammers and screen bars for service crushing PRB is an example of us improving the life and lengthening the periods between maintenance. We do some with hard-faced. The customers have used it, really appreciate the extra life that they get out of those parts. We're also moving to improve some of the interiors, such as the Jeffrey Easy Access. We're also looking into replaceable head hammers and machines. So we're looking into continuous improvement. And as I said, we have our lab there, that we have all brands that we're continuously looking to improve on our existing parts and equipment.
I've got a question. John Zeiser from Zycorp. I had the privilege of in February looking at down in Duncan the test lab. But can you go over the test procedures on if someone sends in material, how long it takes to test, or do we have any charge for the test, or how we handle that?
As far as the testing, the length of the testing depends on the customer's specific needs and the number of tests that we actually perform to optimize the yield of their output product. Sometimes, for instance, on a chip sizer test, we usually only end up with 4 or 5 test setups in the machine, which can easily be done in a couple of days or less. By the time you set up the machine for the various arrangements, do the classifications after the testing, bag it all up, and then our lab people write up the formal reports to go back with the test samples to the customer. The other tests can be more extensive. We've done some coal testing and potash testing. We just recently did some solar salt testing, which can extend, more than 1 or 2 days, actually a week or longer, to get all of the different testing done. We also recently did a coal test that was actually done on various brands of equipment in the lab to compare the Gunlock and the Pennsylvania Crusher and the Jeffrey Rader type of crushing equipment, and we compared the results of all the different brands for that specific customer's needs. And at the end of the day, or the end of the testing, so to speak, the customer had his choice of good, better, best selection from the standpoint of product yield, economics of initial capital investment, and projected maintenance cost to operate the different types of machines and the amount of yield that they were going to get with the different setups. So there's lots of benefits with the new lab arrangement that we have configured that we can do now that we couldn't do in the past. And we're always moving forward. Customers are always welcome to come to Duncan and witness their testing if they desire. We love to have customers come see the lab. It's open to anybody that wants to come. We just need to know ahead of time, so we have to make sure we have the right personnel on hand to accommodate them. As far as testing, the cost of testing varies. Again, depends on how extensive the testing is going to be, and that will be handled on a one-on-one basis with each customer as to the test requirements, and can range from nearly nothing to several $1,000s, depending on the amount of time and the resources required. So we'll be happy to give you estimates ahead of time as needed. Does that answer that entire question? I know that was a multi-faceted question, but hopefully I got all of it covered.
Yeah, that's great. Thank you.
I would just like to add that we did a previous webinar on the Development and Demonstration Center, and it covers a lot of that information in a lot more detail if you're interested, and that's on our YouTube channel and on our website.
Okay, I guess we'll wrap it up. Again, thanks everyone for stopping by, and we look forward to speaking with you in future webinars. And if you have any individual questions, you can contact us directly. Thank you.
Thank you, everyone.